Next segment is going to be brought to us by Tyson Schey. Tyson's from Cummins. Cummins was one of our initial sponsors for this event. They've been great supporters for us. As you all know, Cummins do a fantastic job for our industry, primarily marine propulsion up to 715 horsepower is where we see most of it. They also do much bigger and more commercial projects. We see, but the bulk of it, though, primarily in the smaller horsepower engines. Talking to us today is going to be Tyson Schey. Tyson is currently a technical project leader at Cummins, working with marine customer and with the Marine Customer Engineering Group. Areas of focus consist of propulsion systems, integration, electronics, human-machine interface, and vessel-level validation. Example product launches include the Cummins inboard joystick docking system, Cummins CCommand Connect engine information system. He grew up with his father in the marine industry. Boating has been his personal and professional passion. 14 years of career experience, span boat builders, propulsion providers, and include work with Brunswick, the brands being Meridian Trophy, Maxim, and Bayliner, Mercury Marine, and Cummins. Tyson has his BS in electrical engineering and physics and lives in Charleston, South Carolina, along with his wife, daughter, and mother. Tyson Schey from Cummins, everybody.
Thank you. All right, so first thing, I got to start the timer. That way I can keep track of where I'm at. So, thank you so much, Paul. Appreciate the intro. And to everyone here, thank you for the opportunity to come and speak with you today. We always value these dialogues because at the end of the day, the industry coming together, getting feedback from our customers is central to make sure that we're working together to solve our customers' problems and advancing the technologies and the solutions as a whole. So, clicker, there we go. All right, so what am I going to talk about? I want to talk to you today about Engine Information Systems, or EIS. So you're going to see some overlap here with Peter's presentation from Jameco earlier. I'm going to take a bit of a twist on it and delve into some of the specific considerations as it pertains to the engines, or the heart of the vessel. So when we talk about EIS, we're really talking about the system that helps the operator understand the status of the engine, if there's any issues, and also can provide key maintenance information. It's used by many different entities. Obviously the captain, but then the crew and service technicians is a key user of these EIS solutions. We also have to make sure that we understand that it comes in so many different varieties, depending upon the type of vessel, the age of vessel. Is it a simple lamp system, or is it a more complex distributed digital dash with numeric readouts? And at the end of the day, now with these complex systems, it's intertwined with everything else in the boat. So it's not as simple as just an engine system anymore. So why is EIS important? If we do EIS correctly, it helps keep the captain informed, it helps him respond to emerging issues, and it overall, from ownership perspective, maximizes the uptime of the vessel application. If you don't do EIS correctly, then there are some risks. The worst case scenario being a potential safety situation for the vessel and for its crew. We all know that for boats, no propulsion means no brakes, means no get-home capability in a heavy sea state condition. Having a proper EIS makes sure that the operator can stay ahead of emerging issues and respond accordingly before they become a hazard situation. In addition, there's also potential warranty aspects. So now we're talking money. Money's always the big part, right? Most OEMs have particular requirements for the EIS, and if they're not satisfied, that may impact the available warranty for the engine application. So why are we going to talk about it? Because of the ever-growing complexity in our vessel solutions. It's not as simple as it used to be, and there's many more considerations than ever before. In addition with that, the ever-progressing technology that we have available to our customers throughout the world in other markets also means their expectations are constantly increasing. So now they need more accessibility and nature and detail of information than we ever used to have to give them, and they demand it. So, there we go. A few quick examples. These by no means are all-inclusive, but just to set the baseline of where we stand. You've got your dedicated digital displays, kind of the standard of the past decade or so. These aren't tied in with other vessel systems, but would be part of like an electronic engine solution. Otherwise, you have the traditional dedicated needle and dial face gauges. Now, I call them needle and dial face because that's the type of readout. That's a sweeping needle. You don't necessarily want to call them analog or digital because that really defines the nature of information that's being fed up to it. Where is the info coming from? But it's the gauge readout and how it's presented to the operator. And then, as we all know, the more modern solutions with a multifunction display where you no longer have dedicated displays, but everything is integrated into one common glass dash for the operator. Or full custom solutions that could be PC-based, PLC-based, you name it. All right, so now that we know a little more about what an EIS is, what we're talking about, let's look at some of the considerations you really need to take into account whenever you're dealing with EIS. And this could be for a first fit application, speccing out the first time, or for aftermarket service. It really comes down to 3 questions from my perspective: the who, the what, and the how. And we're going to cover each of them. So on the who front, it's most important to understand who your customer is and what their expectations are. And this plays out in a lot of different ways. How do they want the information presented to them? Do they want the digital glass dash? Do they want dedicated needle and dial face gauges? And then also, their experience level is a major role in this. A professional captain is going to have a lot more familiarity with engine systems than an owner-operator who may be a novice. In addition to that, the professional captain may want to actively monitor engine status parameters on their own, where an owner-operator may just want a simple, hey, is it green to go or red and I got to do something about it? What? There's a few different parts of the what. What applications? Are we talking a displacement hull or a go-fast boat? A multiple engine application, a hybrid application? All these factors are going to impact the types of parameters that are pertinent to the vessel captain. In addition, once you've identified the specific components involved, who supplies them may have a major impact as well. There could be minimum requirements from the manufacturer. To give you an example, on a Cummins propulsion engine, we mandate that there's 4 parameters available: RPM, oil pressure, coolant temperature, and battery voltage. In addition to that, we mandate that the operator get alarm capability for low oil pressure and high coolant temperature. Now, we give you a lot more information than that from our engines, but those are, at the end of the day, the only things you have to have. And we don't dictate how it's done, whether it's a lamp or a horn or a gauge or a needle, whatever. You can do it however you want, but you got to have those things. The flip side is there are sometimes applications where you are constrained in the physical or technological solution that you can use for your EIS. A good example of these are the more complex integrated solutions for propulsion, like a pod system. A Zeus pod propulsion system is part and parcel with a SmartCraft engine information system. So if you have a Zeus pod, you know you're going to have SmartCraft EIS. There's no 2 ways about it. Another aspect of what? What sources? Where's the information coming from? This comes back to, is it analog or digital? If it's digital, which is most likely the case nowadays, what type of digital connection? Is it open source or proprietary? Is it J1939 or is it NEMA 2000? All influencers when we're dealing with these things. And then finally, how is it interfaced with other systems? Again, from the Gemeco presentation, are there telematics? Are there other third-party solutions that are in there? Is there remote vessel monitoring? These can also intertwine with the engine information systems we deal with today. They're no longer just engine systems. They're now complete propulsion and vessel monitoring solutions. Okay, the last part of considerations, the how. So we've defined what the expectations are, who's using it, some of the different what it looks like. Now, how do you actually go make that happen? And this can, at the end of the day, for the dealer network, be the most important part. Where do the parts actually come from? Who do you call when it comes to service? There are different solutions here, and there's trade-offs to each. When you're dealing with a third-party solution, you often get a lot more tailorability, a lot more customization. You can do things that may not be standardized. But you may not have as readily available documentation for installation or for troubleshooting, or as global of a network for service support. Also, when you're talking about an OEM solution, OEM solutions will normally have a little more information available because they'll put a proprietary twist on what would otherwise be the generic available information for third-party systems. All right, so we've defined engine information systems. We've talked about some of the key considerations when you're working with them. Now I want to walk through some of the pitfalls or watch-outs when you're dealing with these EIS solutions. There's a few aspects: networking, alarm communication, how systems overlap or integrate with one another, and then also if you come into the situation of having to modify an existing solution. Okay, networking. So we've heard a lot today already about NEMA 2000 and J1939 being standard protocols. Well, unfortunately, even though they are standard protocols, they're very commonly not plug-and-play protocols. There's a degree of technical detail in the setup to make sure that everything is communicating properly with one another. Think of it as basically there's going to be the talker, the engine, where your data is coming from, and the listener, the display. So when you're ever having a conversation, the talker and listener needs to know who's talking, who's listening, what language is being used. Before you ever get into one of these things, always try to understand up front how the talkers are going to be identified. That would be a source addressing strategy on NEMA 2000, or an engine instancing strategy on, source addressing strategy on J1939, or an engine instancing strategy for NEMA 2000. And then also make sure you understand the parameters you're interested in. That's going to define the PGNs that you need to look to, basically the specific messages on the bus, like Peter was talking about earlier. If you understand the talkers, the listeners, and the messages, or the language, then you can, before you even get to the application, do a pretty good paper study and ensure you know how to set things up and that the listeners are going to understand what the talkers are saying. That becomes especially important if you're dealing with any type of proprietary messages. And when I say proprietary, I don't mean proprietary in that only the creator can use it. Proprietary refers to when an OEM works on a public open network like NEMA 2000 and creates messages to supplement information already available on the network. So, for example, there may not be a message for engine load. There is in NEMA 2000. Well, let's just say there wasn't. We, Cummins, might go put a proprietary message. We spec out our own custom message on that network. Now, we'll still publish the information. We'll let anybody else use that information. Here's how to read the message. But until you get that translator, that decoder key from us, and put it into your listener, your display, the information's meaningless to you. Okay, another part of networking, gateways. So most of our yachts today are running diesel engines. Almost all diesel engines nowadays are coming from an electronic engine platform and from an industrial application that has then been marinized. Those industrial electronic engines communicate the vast majority of their information on J1939. But because most of our marine vessels are dealing with MFDs and displays in NEMA 2000, we often have to take the data from one and push it to the other. The catch is they're not always one-to-one. Because J1939 was built from the ground up to be engine-centric, it's got a much richer vocabulary about engine systems, a lot more things it can tell you. NEMA 2000, on the other hand, was based initially on vessel navigation and those types of things. So its vocabulary is a lot less for engines. To give an example here, on the alarm side, J1939 has literally hundreds of potential categories of alarms pertaining to diesel engines, where NEMA 2000 and their engine discrete status message has about 20-ish parameters that can come out. Those 20 parameters are more than sufficient for the vast majority of applications, but you have to make sure that you have a good map that links up what the engine is saying to now how you're going to show it on a NEMA 2000 system. Other parts that vary between them is the addressing and instancing strategy, how to identify that talker. On the addressing side, 1939, it does standardize engine 1 is address 0, engine 2 is address 1, so on. But it doesn't standardize which engine physically on the boat gets a particular engine address. So does the starboard engine get address 0, or does the port engine get address 0? There's no spec for that, so it becomes often supplier dependent. So you're going to have to work with your engine manufacturer to understand how their addressing strategy works. On NEMA 2000, it's a little bit different. NEMA 2000's thought through this, and since it's marine-centric, has established that the port engine is always going to be instant 0, and then it's going to increment up from 0 over to the starboard side. But what this means now is it's not fixed. The number of engines you have on your application is going to change which engine instance the starboard outer engine is. So give an example here. This is one Cummins application for our B&L engines. We've fixed for our internal conventions the starboard engine to always be address 0 and the port engine to always be address 1. But that may change if you're dealing with another engine manufacturer or even another platform in our own portfolio. On NEMA 2000, because it's dependent upon the number of engines, you're going to have to change your cross-reference table depending upon your unique vessel application. Next area of watch out, alarms. This is probably the most important function for an engine information system, telling the operator when something is wrong. Unfortunately, while it's the most important thing, it's also one of the least standardized aspects of engine information systems. Many different suppliers present the information to the operator in very different ways, and sometimes potentially confusing or conflicting ways. So this is an area that we have to work through as an industry to make sure that we're consistent and providing the most intuitive operation for our captains as possible. When we're thinking about alarms, there's a lot of variables. Now, these aren't standardized terms. I've kind of made these up, but it helps define the things you need to be looking at when you're talking about engine alarms. There's communication. How is an alarm enunciated to the operator? Is it audible? Is it a pop-up? Is it a lamp? After it's been communicated, how is it identified? This means, is it indexed with a particular number? We've all been there when we're on the phone trying to help somebody troubleshoot, and they're describing what they're seeing to us, but they're not really describing it correctly. They lost something in translation, and you're helping them troubleshoot the wrong thing. Getting that particular fault number, make sure that you know exactly what's happening when the customer tells you they have a problem. There's the description. This would now be, what is the operator told about the fault? And this is the biggest area that there could be some intuitiveness problems on displays. Often, this is techno mumbo jumbo from like the SAE spec, and the commoner isn't going to really know, oh, why does oil rifle pressure range critical high, what the heck does that mean? Oh, well, it means I've got an oil problem and I got to do something about it. Making those common terms more transparent is something that's important when you're dealing with generic applications that are just reading default spec information. Severity. This is something that is not standardized in all the different network systems. For example, NEMA 2000 has no association of severity on their engine discrete status message. G1939 does. That's another one of those fidelity losses when you're gatewaying information. And the last two, these have no standards whatsoever, but they're things we should really be thinking about. Do you give the customer a recommended action? How do they now know how to respond to an issue? Let's give an example here. We have certain engine situations where if a particular sensor goes out, it may not impact the operation of the engine at all. You can keep running just fine and get home. But if you shut down, you won't be able to start the engine back up. So maybe it'd be really important to tell them, hey, you're safe to operate, but don't shut down until you get back to port. And then finally, acknowledgement. With all these systems we have on the helms of vessels today, you can have multiple horns, multiple displays, multiple things blaring at you all at one time. Having the ability for the operator to acknowledge, okay, yes, I understand that there's an alarm going on, but I'm in a situation where I'm choosing to continue to operate my vessel to get home safely or to avoid a collision, something like that. But I need this system to be quiet so I can get back to running the boat. That is something that's not standardized, and it has to be carefully considered when you're interfacing multiple third-party solutions. I'm not going to go through this in detail. You have it for your reference later, but it gives one example of the actual SAE, J1939, and NEMA 2000 spec information for one alarm, oil pressure critically low, a pretty important one. You can see here there's no lamp or severity on N2K where there is on 1939, but neither of those have an audible specification or an acknowledgement specification. If you get to a proprietary implementation, like one of our Cummins displays, we have displays that have some of those solutions in place. But again, that's a case by case. Another watch out, overlaps. Just because there's the same information being presented in multiple areas doesn't mean it's presented in the same way. So one display might present fuel level as a percentage. Another display might present it as a volumetric number of gallons remaining. How does the operator know what they're used to? These are things when you're combining multiple applications together, either first fit or adding aftermarket parts, think about how to commonize it. And then we just got through talking about alarms. That's a big area to commonize. This is probably the area that we have the best ownership and opportunity as an industry to improve our interfaces over the coming years, is adding to the standards, like the NEMA 2000 standards, so that we can better improve the consistency of how information is given to operators and their ability to interact with displays. Finally, existing systems. So when now that we have these digital systems that are networked, often a lot of the networking aspects is dynamic. The addressing may change on a device if you plug a new device into a system. So if you go to a boat that's got a stable working system and then change something, update software, add another display, tie in a telematics system, you may unwittingly impact the original engine information system. So it's always best practice when you're touching a system, new or old, to verify the key functions on all systems for the EIS, not just the thing that you've been working on. All right, so how do we tie this together? Here's an example, a Cummins example. We've recently launched a product called CCommand Connect. It's a OEM customizable engine information system solution, and it touches all the elements that we just talked through. So in this system, to give you some examples, we're able to monitor analog sensors from our transmission and gateway those onto 1939. We also, of course, have the engine systems, which is inherently 1939. So now all of the information is available digitally on 1939 for both the propulsion, the transmission, and the engine. There's the capability to gateway that 1939 information over to NEMA 2000 information for an MFD or whatever else needs the customer may have. And then there's also options of how you're going to do a J1939 solution if you choose to go that route. You can get a display from us. If you get our display, you'll then get some of those quote-unquote OEM tailored or proprietary benefits, like we've taken it upon ourselves to simplify the fault communications, to put recommended actions in, and we'll even help you if you want to take a third-party display and have it say the same thing our display says. We'll give you that information. But there's an option from us, or you can do your own. That all ties together to be a network system with all these different elements, both analog and digital, both J1939 and NEMA 2000. So the flexibility is greater than it ever has been. But that flexibility also means there's a lot more questions to ask and to answer as you're going through it. So, wrapping it up. We've talked about an EIS, and we've learned that it's crucial to safe operation, to supplying the customer information, and to the overall owner satisfaction of the vessel. Engines being the heart of the system, it's pretty crucial. We've talked about how the evolution of information availability has made a lot more capability than we've ever had before, and that the expectations are growing on that. But that extra capability also drives now new complexity. And that complexity is something we have to work through and be prepared for up front whenever we're dealing with these customer issues. How do we best contend with this complexity? It's communication, communication, communication. At every step of the process, all parties that are involved, the customer and their expectations, the display supplier and their capabilities, the engine supplier and how they talk, and then ultimately the installer doing either the servicing or installation work, all need to get on the same page. And if you can do that up front, it'll go pretty smoothly because it is relatively standardized. But if you just start trying to do things ad hoc, things are going to get out of whack and you're going to end up in some tricky situations. At the end of the day, for all of us, these systems are about making boating easier, more intuitive, enjoyable, and trouble and worry-free. If we do that, we all get to sell more boats. So we thank you again very much for the opportunity to come out. Please come up with any questions, and I'll be here for the entire rest of the day if you want to talk offline.
Questions, anybody? Actually, I have a question. Is there the potential or the possibility let's say you have an issue with an engine. Is it possible for a technician to poll from the boat a code or an alarm that has been sent so that he can diagnose a problem and come prepared to fix it?
Absolutely. So there's a few different scenarios there. Now that you have these digital solutions with J1939 and N2K, anybody that has a remote vessel monitoring system, telematics, quote unquote, they can query the engine systems for both active faults and then what's called inactive faults or historic faults. And depending upon the level of that engine information system and how it's interfaced with your engine OEM, you can get a whole different smattering of information. The most basics, pretty much anyone from any supplier, you're going to be able to get the fault code number and that type of stuff, which is a great starting point. But some suppliers will also do actual data monitoring telematics solutions. So you can work with Cummins and our distributed networking and remote monitoring teams, information diagnostics teams, and partner to get more advanced diagnostic capabilities, similar to like the diagnostic capability you'd have on a service tool for an actual Cummins technician. That's the next step in these types of technologies, is going from just getting the basic information any operator can have to getting this very advanced, in-depth troubleshooting for diagnostics on an engine.
Awesome, thank you. Thank you. Any other questions?
Just as a matter of curiosity, what percentage of the Cummins industry does the I'm going to say, what percentage of the...
Here's your microphone. Here's your microphone while you formulate your thought.
How much of Cummins' total business is represented by the marine industry? In other words, how many...
Pleasure craft. Marine pleasure craft.
Boats.
So it's...
What percentage of Cummins engines are on boats versus everything else that you do?
Well, it depends. So if you include our larger horsepower commercial offerings, depending upon the overall trends in oil and over-the-road applications with trucking, marine can be a relatively significant percentage of the Cummins sales. But as a whole, normally marine is smaller side. So majority of Cummins is going to be on the trucking and that side, but then this is one of the other markets that we can leverage the volumes from those other industries and bring those technologies to bear in marine.
Excellent.
I don't have a hard percentage number for you. I can get it if you'd like afterwards.
All right, Tyson, thank you very much. Excellent presentation.